This chapter talks about the basic operation of a SIMATIC controller and about how the various memory areas are organized. A controller is the core component of every automation system. It ensures the smooth operation of production machinery, manufacturing systems, and technical processes. SIMATIC controller consists of hardware, firmware, and a user program. The firmware organizes all control tasks not connected to the actual user program, such as startup, reading of input signals and writing of output signals, as well as the call-up of organization blocks, OBs. Organization blocks are the interface points between the firmware and the actual user program. The user program itself contains all modules and functions needed for the processing of your specific automation task. You create it in the TIA portal and then download it to the controller. In SIMATIC controllers, the user program is generally run cyclically. That means the controller works through the program and is then restarted on an endless loop. Let's map out the user program from the programming device across the various memory areas of the controller. The first step is for the user program and the hardware configuration to be created as an offline project via the TIA portal. In the next step, the project data is downloaded to the load memory of the controller. The load memory retains all data even after a voltage failure. The integrated load memory of the S7-1200 was designed for this. It can also be replaced with a higher capacity SIMATIC memory card if needed. The load memory for the S7-1500 is always located on a SIMATIC memory card. Once downloaded to the load memory, the firmware of the controller interprets the project data and then parameterizes the modules associated with the controller during startup. The code needed for the processing of the program and all associated data are transferred from the load memory to the internal RAM of the controller during the transition from the operating state stop to run. The inputs and outputs are not directly accessed in the user program. Instead, they are written to a specific memory area known as the process image. This process image is updated by the firmware for each new cycle. This provides the controller with a consistent image of the process signals available for the duration of each cycle. Important data is written to the embedded retentive memory when the controller is set to stop and will be available again at the next startup. You define during programming which data is to be handled as retentive. The SIMATIC S7-1200 and 1500 controllers have an optimized data filing system. This system significantly reduces memory requirements and access times. During programming, tags are no longer addressed absolutely, but symbolically. The TIA portal monitors the assignment of the symbol to its memory address. In other words, the change of an address or tag name triggers an automatic change of all use instances as well. How does that look in the TIA portal? Once a controller has been created in the TIA portal, the cycle OB main will be available in the folder Program Blocks. Under Program Info and the tab Resources, you can see the actual hardware memory capacity used for the configured CPU in the programming objects used, the assignments of the various memory areas in the CPU, and the assigned inputs and outputs at the available input and output blocks. There you can see how much memory your project currently needs. The available memory capacity is exceeded in areas where the memory load value is displayed in red. Here you can state the available load memory of the SIMATIC memory card. You can even see the memory capacity used for each of the program blocks. Also noteworthy, here you can see 2 data blocks, in short DBs, with the same content. Only one will be optimized. The non-optimized DB contains an additional column, offset, with its absolute addresses. In both cases, the access to the tags will be symbolic. For optimized DBs, an embedded retentive memory can be set up for each individual tag, while for non-optimized DBs, only one can be set up for all variables. The Simatic controller model offers a high-performance firmware which optimizes the use of your available memory capacity and which allows symbolic programming.